So I've been making more progress with the Crystal Sync project, and what I'm doing just now is just mounting the shutter position sensor. So that's a TCST1103 sensor, which just basically consists of an infrared LED on one side and a photodiode on the other. And I had it in a test circuit earlier and it was working just fine, so the shutter just basically passes through that, and I'll have an interrupt on the Arduino so that when it passes through there, basically I'll just count a frame. So every time that a blade passes through, it's just going to count, hopefully anyway. With the Arduino, apparently you can have there's two interrupt enable pins, so one of them is going to be a timer interrupt, and the other one will be an interrupt for the shutter, so it should hopefully work. So this is the controller box that I've got put together so far. So the camera is going to have to run on about 30 volts. That'll come in there, and then that plug there goes to the motor, and then this plug here is going to go to all the sensors and buttons inside the camera, which I'm going to put in place. Another feature I'm going to have is, so I can sync up my audio properly with my video, is since this camera ramps up to speed, I'm going to have an LED which shines on the film, a red LED that shines on the film while it's ramping up to speed. So I'll be able to see when I scan my film, like any frames with red in them, those are the ramp up frames, and I'll just discard those, and the audio starts just after the red frames. And I also need an output for a buzzer as well, so that after the camera's ramped up, it'll beep quickly, and that'll be picked up on the audio recorder. So I haven't shown this very well, but the way the motor is mounted is, this is a NEMA 23 stepper motor. I did have a raised portion here, but I've had to file down the whole front of the motor so it's flat. And as you can see, I've just slotted the shaft like that, and what happens is that goes in through the side, and just get it turned the right way, and just engages with the mechanism in there. It's just engaging there. As you can see, it's got a flat part on it, and it just drives this shaft here. So the motor controller runs on 30 volts, but the Arduino and everything else is going to need 5 volts. So I've got a linear regulator module here, and I'm using the linear regulator because they don't give out as much noise as the DC converters do. It'll be a little bit inefficient, but what I'm going to do is just glue it in here. I've moved the regulator forward on this board, and it's basically just going to sit inside there like that, heat sunk to the case. So I'll be able to actually put quite a lot of current through it. I'll probably get away with probably putting 100 milliamps through it at least, but I'm not going to need anywhere near that. So that's basically how my powers, that's where the 5 volt power for everything else is going to come from. The exposure meter, I don't know, I might just keep that powered by battery, a separate battery there, but I might figure out something to power that. I could maybe just power it off a voltage divider, but I don't know. But yeah, this box basically, I've cut a hole in it, so that's the heat sink for the motor controller in there. So when the motor's mounted on the side, I've worked it out that that's basically where that heat sink pad is going to be. So I'll put thermal glue on there, bolt this to the side of the camera. No, in fact I won't use thermal glue, I'll just use thermal grease. I'll put some on there, and this will be bolted to the side of the camera too. And I'll have the screen on the front, as well as a button for single frame, and maybe another button for putting the camera into reverse. I don't know. But I'm going to have to let the glue on this sensor cure, and then I'll get the camera wired inside, get all the components inside that I need, and I'll put the motor back on. And then once I've got all the hardware set up how I want it to be, I'll have to program this thing, which is probably going to be quite difficult. So it's going to take quite a while. But the project is coming on quite well.